Okay, this problem says a 2000 kg railway freight car coasts at 4.4 meters per second underneath a grain terminal, which dumps grain directly down into the freight car. If the speed of the loaded freight car must not go below 3 meters per second, what is the maximum mass of grain that it can accept? Alright, so here's grain being dumped. And here's the Alright, so the problem is as follows. You get an empty car coming, moving in this direction, and as it gets underneath this thing, this grain, whatever you want to call it, that grain gets dumped in the car, and it slows down. Okay, and then what you don't want happening is it's slowing down less than 3 meters per second. Okay, so and you probably want that because you want a certain rate of flow for the cars. Okay? And now this is you can treat this as a collision problem. Okay? Now in collision, what is it that is true? The momentum after the collision is equal to the momentum before the collision. Okay, so this is before the collision, and this is after the collision. Okay. So the momentum of the car after the collision is mass of the car. Here the mass is changing, and that should equal initial mass of the car then and initial velocity of the car. Okay. So that's 2000 kg freight car, so that would be 2000 kg. Initial velocity is that, and if the speed, what is the maximum mass of grain that you can accept? Okay, so let's do this. Final mass of the cart is initial mass of the cart plus mass of the grain. Initial mass of the cart is 2000 kgs. Initial velocity is 4.4 meters per second, and final velocity is 3 meters per second. Okay. So let's put all that stuff in. 2000 plus mass of grain times 3 meters per second, and I'm not putting any of the units there. Let me make sure. Mass of grain, don't confuse that as mg. Okay. So 3 times mass of grain is equal to 2000, 4.4 minus 3, so 1.4 times 2, 800. Mass of grain is okay, so roughly 1000 kg. Okay. Again, the principle here is we are treating this as a collision process. Okay. So here was an empty car going, and what you do is so you drop the grain straight down, so there was no force on the cart in the direction of its motion. Okay, and so that force, any force that was being exerted, would be balanced by the normal force. Okay, all right. Any questions before we move on to the next problem? Did you say something to him?